It's convenient to have a list of all the uses of a variable. So this list is called the use list of a variable, and it contains instructions in which that variable is used. This list obviously takes needs memory, and it's not always used by all compilers on which use SSA form. Okay, but it's convenient to have it. And when we have changed the value or our view of the value of a variable from undefined to constant or from constant to non-constant, then we want to re-evaluate the executable instructions which use this variable. Okay, so which instructions are executable? It's all the instructions which are located in a vertex which have any incoming edge that is marked as executable. Okay, what does it mean that edge is marked as executable? It means that we have added the edge when interpreting a branch. So in this case, both V and W, I mean these edges are regarded as executable, and we regard the corresponding V and W vertices as executable as well. Okay, so the constant propagation algorithm, it uses two work lists. First of edges in the control flow graph, and then of instructions which need to be re-evaluated if they are in a vertex which is executable. Okay, the algorithm can take elements from these work lists in any order, and it doesn't matter for correctness, and the result will be the same. It's important to know that we do not modify the tree address code until after interpretation is complete. Since we may think at the moment of this interpretation that the instruction produces a constant, but later think that it does not. Okay. A question is, where should we store the constant during the interpretation? It can either be stored in the instruction or in the variable. It doesn't matter. It's essentially the same, since a variable can only have one instruction which defines its value. And the best is to store it so that it takes as little memory as possible, which means estimating whether we have a larger number of instructions or a larger number of variables. Exactly how to represent the data structures is not concerned in this lecture. I mean, we are not concerned with that in this lecture. I can mention that it's for languages such as C or C++, which have a union, which is like a class or object in which only one variable at a time is actually available or requires memory. Then it's convenient to use unions to not have all the attributes in memory at the same time, but only the attributes which are actually needed by an algorithm. Okay. So what do we do during when we visit a new basic block? Well, the first time we come to a basic block, we interpret all instructions. First come the phi functions and then the other instructions. But it's only on the first time we visit this basic block that we interpret all instructions. On subsequent times, we only interpret the phi functions. And why is that? Well, we need to reinterpret the phi functions since we ignored the operand corresponding to this edge previously. So therefore, the phi function may produce a different value, and we have to evaluate it. The other instructions, they will be re-evaluated due to processing of the SSA worklist. I mean, they will be re-evaluated if needed. So this is the main algorithm. We start with setting, for each definition, we set the value of this definition. And that means either the variable or the instruction, depending on how we represent this, to the unknown. And then we set each vertex as not visited. Okay, and then we visit this vertex. I mean the start vertex. Then we go through the work lists until they are empty. If it's an edge, then we check if it has already been marked as executable. If it has not, then we set it as executable, and then we visit the basic block corresponding to the head of this edge, the destination of the branch. Okay, and if it's an element from the SSA work list, we take a statement, I mean this statement, and check in which vertex it is located, and then if there is an executable edge into that vertex, we visit the statement. We will next see what it means that we visit the vertex and visit the statement.